Good morning. Today we're going to start looking at polar coordinates. So we've been looking at the rectangular coordinate system. So now we're going to look at polar coordinates. So rectangular, we have an x-axis and we have our y-axis, and we plotted a point and it was just an x and a y normally. So with the polar coordinates, you are going to have an r value and a theta value. And the theta value is going to represent your 0, your pi over 2. It could be in radians or it could be in degrees. Pi, 3 pi over 2, and then the values in between. So theta represents your angle that you're going to be moving around this center. And then your r value here is going to be the distance. From the center. Okay. So your r is going to be your distance from your center, and your theta represents the angle that you are going to move around. Okay. So when r is negative, well, let's not do that real quick. Let's just plot a point so that we can kind of see what I mean. So if I wanted to plot the point 2 pi over 2, that means that my distance is going to, my radius, or how about my radius, distance, your radius, is going to be 2. So you're going to have these radius, remember like our unit circle that we've been dealing with? So if we have a radius of a 1, it's just our unit circle, a radius of a 2. So this ring here would be represent a distance of a 1. This one would be represented distance of a 2. This one would be represented by a distance of a 3. And we could keep going forever and ever, and this will be a 4th here. So we're going to get bigger and bigger and bigger as our radius gets bigger. So if our radius is a 2, then this is going to be the second ring right here. And then it's going to be pi over 2, so it's going to be right here. So that is your point A here. If I said 45 degrees, so I'm going to be on a radius of a 3. And where is 45 degrees? Where is 45? That's going to be in quadrant 1. So it's going to be roughly in the middle here. So this is going to be point B. If I said 4, negative pi over 3. So 4 would be on this. Sorry. It would be on the 4th ring around there, and a negative pi over 3 is going to open this way, counterclockwise, right? So negative pi over 3 is going to be somewhere down there. So that would be your point C. Okay? So that's how you plot your points. If r is negative, we graph, oops, sorry. So we graph the point positive r, and then we'll add theta plus pi, so 180. Okay, so this is what I mean by that. So let's just say we want to plot negative 1 pi over 4. Okay, so what I'm going to do is I'm going to change what I'm going to graph is 1, and I'm going to say pi over 4 plus pi. So So that's going to be 1 5 pi over 4. Where is 5 pi over 4? So 1 is here, right? Your first little ring. And 5 pi over 4, this is pi over 4. 3 pi over 4. 5 pi over 4. This is going to be right here. Okay. All right. So y'all graph these for me. Okay. So we're going to have a ring 1, our ring 2, our radius of a 2, and a radius of a 3. So 2, 7 pi over 6. So where is 7 pi? This would be 6 pi over 6. So 7 pi over 6 is going to be in this quadrant. So there is going to be your A. B, 3, negative pi over 3 here. So it's going to be on the third ring here. And it's going to be a negative pi over 3, so it's going to open negative. So it's going to be about right here. All right. And now C, we change this into a positive 3, and then we're going to say negative pi over 6 plus a pi. So we're going to have 3, and that's 6 over 6 basically, right? So that's going to be a 5 pi over 6. So I'm going to do the outer ring, so 3, and then 5 pi over 6 is 6 pi over 6 is right here, so 5 pi over 6 is about right there. So remember, this is 0, pi over 2, pi, 3 pi over 2, and then I'll back up to 2 pi. Okay? All right, so when we name our polar coordinates, we can also have different polar coordinates that represent the same point. So if I'm given this R polar coordinate, it can also be represented by just saying R and then theta plus 2n pi. Or we can change it to a negative R. And so if we changed it to a negative R, then we'll say theta plus pi, right? Because that gives us the, and then plus a 2n pi. So that gives us the negative R. So if it was a negative radius, and then if we had a positive radius. All right, so, and then n just represents an integer. So where n is an integer. All right, so name 3 different pairs of polars okay, where theta is going to be in between negative 2 pi and 2 pi. All right, so let's look at this one here. So 2, so the radius of a 2 and a 5 pi over 3. All right, so where is 2? So let's think about this. So 2, 5 pi over 3. So 5 pi over 3 is somewhere in the 4th quadrant, right? Okay, so right here. All right, so it could also be 2 with a negative angle. So it would be what, 2 and a negative pi over 3? Okay, and then now if I change it to a negative 2, so remember negative 2, so I would have to basically plot this point up here, okay, to make it be, or I guess technically that point up there. So what I'm going to do is I'm going to say 5 pi over 3 minus a pi. So I'm going to subtract a pi here. So instead of adding a pi like we would in our normal, so think about this for just a second. So when r is negative, we change the r to a positive and then we add pi. So we're going the opposite direction, so we're changing it to a negative, so that means we would need to subtract a pi here. Okay, so this would be a negative 2, and then that would be a 3 and a 3, right? So that would be a 2 pi over a 3, right? And then let's change it to a negative as well, so negative 2. And then we could go another unit around, so this would be 5 pi over 3 minus a pi, right? Minus a 2 pi. So this would be a 3 pi, so that would be a 9 pi over 3, so that would be a negative 4 pi over 3. Okay. Alright, I'll do this one for me. Okay, so for this one, we are going to change this to a positive 5, right? And then we will do what here? So then we'll say negative 7 pi over 4 plus a pi here. So this will be a 5, and then a negative 3 pi over 4, right? So where is a negative 3 pi over a 4? So that's where a negative 3 pi over 4 . So negative 3 pi over 4 would be about right here. Okay, so the same point here is going to be 5 and a negative 3 pi over 4. Okay, so that's one way to find a point, right? And then what else is the other way to find the point? So if I had a negative 5, pi over 4, right? Because if I did the negative 5 pi over 4, that would have given me the same 3 pi over 4. And then if I change it to a positive again, so if I change it to 5, and I've got negative 7 pi over 4, and I add a 3 pi, so that would give you what? 5 and a 5 pi over 4. So there's your 3 quadrants that are going to be the same point as that. Okay. All right, and the third thing that we're going to do today is polar distance. Okay, so we are going to have a polar coordinate, we'll call it R1, theta 1, and our second polar coordinate, we'll call that R2, theta 2. Okay, on the polar plane, then the distance between the 2 points is going to be given by r sub 1 squared plus r sub 2 squared minus 2 times r sub 1 times r sub 2 times cosine of the angles subtracted from one another. Okay, so this is the distance. Okay, so basically what I'm looking for is if I had 2 points and I wanted to find the distance in between there. Okay, so let's find the distance here between 2 pi over 3 and 3 7 pi over 4. Okay, so this is your r sub 1, theta sub 1, r sub 2, theta sub 2. So your distance is going to be the square root of 2 squared plus 3 squared minus 2 times 3 times cosine of 7 pi over 4 minus pi over 3. So that's going to be a what? So 4 plus a 9 minus, when I subtract here, so 7. Whoa. My daughter was playing with my calculator. So that'll be a 12 cosine. So when I subtract these, the common denominator would be a 12. So 7, so that's 21 minus a 4. So that's a 17 pi over 12. So when you're in radians here, make sure your calculator is in radians. Okay. I don't think mine is. Yep, it is. So I'm going to put this in my calculator. So square root of 13 minus 12 cosine of 17 pi divided by 12. So that's going to be 4 point. So the distance is going to be 4.01 units. Okay. All right, so you'll find the distance here between these 2 points. And then this is where we're going to stop today, and then we're going to finish tomorrow. So you're only going to be able to do a little bit of your homework. So that's your r sub 1, theta sub 1, r sub 2, theta sub 2. So the distance is going to be a negative 1 squared plus a 5 squared minus a 2 times negative 1 times 5 times cosine of 2 pi over 3 minus an 11 pi over 6. So this will be 1 plus 25 plus 10 cosine 6, 2, 4. So it's a negative 7 pi over 6. Okay, so remember cosine, the negative cosine is the same thing as the positive. Remember, it's even. So this will just be the same thing. So in our calculator, we can put square root of 26 plus 10 cosine going to be 4.16. Okay. All right, so you can do your homework now for these two things, or these three things actually. And then tomorrow we'll talk a little bit about polar equations and kind of what they look like. All right, y'all have a good day.